All right, well, let's get started here. Morning, everyone. I'm Mike Linton with Parcel, and going to talk to you today a little bit about building IoT solutions for global deployments. Bear with me as I have to manage two computers here for the AV setup as we flip through it, so it might be fumbling through a few things, but we'll get through it here. So first, you've probably seen some of these already this week, but just want to thank our sponsors, specifically Quizlet here for the developer track. A few more sponsors. Again, thank you. I think someone mentioned the other day that this is one of the largest free startup events. Did I get that right? Yeah, okay. Obviously, thanks to the sponsors here, so thank you. All right, so just a quick agenda here. I'm going to talk a little bit about our company Parcel, what we do, and spending a little more time talking about the technical side of things, building our IoT solution, deploying it all around the world, and some of the challenges and solutions that we've found as we've been doing that the last 5 odd years. So about me, one of the co-founders of Parcel, CTO, so I oversee all of our hardware, software, data, and technology strategy. My background is mostly on the software side of things, a lot within supply chain, data integration, building various SaaS solutions, advising on other startups, things like that. Based here in Denver. I was previously in Minneapolis for many years, originally from Wisconsin. So, all right, Parcel. Parcel is a data-powered insurance and risk management solution for essential supply chains. There's a lot in there. What does that mean? So Parcel, our overall mission is to reduce waste in the supply chain, specifically around perishable goods. And we set out to do that by collecting the largest primary data set on quality conditions in the supply chain. We started back in 2017, and at that point we were squarely focused on global health and the vaccine supply chain. So it was before the pandemic, really focusing on childhood vaccines, and where the biggest need for that was in low-income, low-infrastructure countries. And so that presented a certain challenge from a technology perspective of having to wanting to collect a lot of data and centralizing it, but also having to do it where there was very low infrastructure around the world. From there, we quickly expanded and realized that the same need was within other perishable markets within the supply chain. What I mean by that is things like food, seafood, fruits, vegetables, things like that, basically anything that degrades due to environmental conditions. And they basically have the same problem. So we expanded our focus from there. And then along the way, we encountered the need for insurance. None of us have an insurance background. We had no intention to get into the insurance world, maybe for obvious reasons, but we found it as a really key distribution tactic. So I'll touch just a little bit on that, why we did that. I won't spend too much time on it. All right. This is our attempt to show kind of how our whole company fits together. Again, trying to give a little bit of context before we get into a little bit more on the technical side. So we consider ourselves a dual market company focusing on two primary markets here. Global health, as I've mentioned, again, focus on vaccines, essential medicines, primarily in low income, low infrastructure settings around the world. And then what we just called cold chain, which is a fairly broad term, but that is anything that it needs protection from environmental conditions as it gets transported around the world. We have two solutions that we offer. On the bottom here is the risk management. That's a little bit of a blanket term for our technologies. That includes the hardware that we design and manufacture, our software, our data and insights solutions, everything that goes into managing risk of goods that get moved around the world. And then our insurance solutions. So that leverages our risk management, our data, to provide actual risk-bearing capabilities for these goods as they get moved around the world. So that way, when things go bad, there's actual protections for those customers. And all of this is supported by our technology platform. So there's a lot of different dimensions here, but one of our key goals was to build a technology platform that served all of it. We didn't want to have a bunch of different siloed products or anything like that. So our technology is intended to serve all of these. Quick history here, started back in 2017. When we set out, we did not want to be a hardware company. We did not want to build hardware. For anyone who's done that, maybe for obvious reasons, it's expensive, hard, millions of failures along the way. And so we tried a bunch of off-the-shelf hardware. Nothing seemed to fit the exact need for us around the cost, the size, the user experience, the design. And we knew that what we wanted to do was introduce a piece of technology into these supply chains, and it was going to cause friction. And so we needed to make sure that we could control all layers of our technology stack, so that way we could build the proper user experience. And that started with the hardware. So back in 2017, we started prototyping, building hardware ourselves. Kind of fast forward here, around the 2018, 2019 is when we started getting a little more smart on the insurance angle. Basically, customers kept saying, this is great, we like what you're talking about, but our insurers would really like this, they would really like the data. You could actually help us understand our supply chain and get us better insurance coverage. So we started getting a little smarter on around that period. We started working with Lloyd's of London and their accelerator program, Lloyd's Lab, went through that. Up into 2019 and 2020, obviously the pandemic hit. So we had already spent a couple years working in global health and vaccine supply chains, and we realized that it was going to be the largest vaccination campaign in human history, and we were kind of uniquely positioned to have a part in that. So we had some projects, specifically some hardware projects in R&D. We accelerated those out and brought them to market, and specifically it was a very small kind of miniature version of our hardware at that time that was focused just on temperature, really kind of targeting those vaccine supply chains and the lengths that they go through. And so that way we could actually participate. And to fast forward, we ended up, and we've monitored a lot of the COVID shipments internationally. A little bit more on today, we have continued to double down on the insurance part. We are a full-scale insurer. We have risk-bearing capabilities, but we've also combined our global health work with our insurance work. We formed what's called the Global Health Risk Facility, which aims to bring the insurance capabilities to these underserved areas around the world where they basically are left holding the bag otherwise if, say, their COVID shipment goes bad once it arrives somewhere, so we can provide the international insurance markets protection. All right, let's talk about our hardware. So these are the different pieces of hardware that we work with. They all monitor various types of environmental conditions, temperature, humidity, light, things like that. The two on the left, we'll talk a little bit more about, because those are the ones that we design and manufacture ourselves, and they are Bluetooth enabled. So that is what we use from our connectivity method. Again, we'll talk a little bit more on just connectivity in general, low connectivity. And the one on the right is a quote-unquote real-time device, or otherwise cellular connected. Again, what we are focused on is collecting data throughout the entire supply chain, and supply chain has points of high connectivity. You come into developed world and you're in a certain port and things like that, you probably are going to have connectivity, but there's a lot of parts throughout the supply chain where there isn't, whether that's in the last mile in remote Africa, that could be in a shipping container, that could be in a congested warehouse. All those different points have very low connectivity, and so we knew that we wouldn't be able to just build a cellular connected device and have it last for potentially a couple-month journey collecting all along the way, and it would be frankly a waste of cost and battery and things like that. So we really focused on building more on the low power, low end, and that's why we use Bluetooth low energy specifically on those devices. The one on the right, just to note, we don't make that one ourselves. What we found is that there isn't nearly as big a market for our specific area for those cellular connected devices. Again, there's certain segments of the supply chain, maybe the truck route or something like that, that there's a great market for it, but we are focused on the end-to-end because we want to, at the end of the day, we want to understand the conditions of the goods once they reach the recipient. This is just one other piece of hardware that we make. This is our gateway product, otherwise called the Parcel Passport. This does one thing and one thing really well, and it automatically sees when our devices are nearby, grabs the data over Bluetooth, and ships it up to our platform, either over cell, Wi-Fi, or Ethernet. This gets deployed both in, say, a rural health facility in Africa, if instead of them having to go check their fridges constantly for the temperature, or say a high-volume warehouse of seafood every time a shipment arrives. Mobile app. So this is our mobile app. Is, again, we'll talk a little bit more about this later, but it's one of the key parts of our platform where in these low connectivity environments, low infrastructure, one of the things that they do have, it might not be any, say, cell connectivity, Wi-Fi or anything like that, but there's a good chance that around the world there's high penetration of smartphones, as probably most people understand at this point. And most of those smartphones have Bluetooth on it, so that was part of why we also pick Bluetooth. And what we can do then is design a solution that even in the most remote parts of the world, they can do their key tasks at hand. So if I'm a healthcare worker in Africa, that means making sure that these vaccines are actually good before I administer to a child, or the fridge that we're monitoring, make sure that's operating well. Or I'm a seafood exporter out of Chile, working on the dock somewhere. I need to understand, send my shipment off around the world. And we've designed it in a way where we can satisfy most of those needs all in an offline scenario, leveraging certain types of firmware within our device and communicating just over Bluetooth. The mobile app does then facilitate the transfer of the full payload of data up to our platform when they do have connectivity. Oops. This is our web application. So some of it is kind of as you would expect with a certain IoT solution. It's where you kind of get the full picture of insights. You get your full temperature graph, manage various things about your company and devices and things like that. But what's interesting here is, again, thinking about this low connectivity idea, there's a lot of little things that we've had to do to still give a quality user experience, even if we don't always have updated data. Because a lot of times people are so used to certain consumer solutions, things are constantly connected. There's little bits throughout your architecture that you're always just assuming you're going to have connectivity. Your users are always going to assume that that data is up to date, up to the minute, things like that. We don't have that luxury. We have data up here. We have to show meaningful insights, but the data might be days, weeks, months old, or we're still waiting for the data to arrive. And so we have to do a lot of little things, even as simple as just communicating that this data is as of a certain time period, or show certain reporting to show what is the frequency that typically you see data. So if you're off that frequency, okay, there maybe is something to note. We also, customers will put in the expected time that data will arrive, so like an expected arrival of a shipment. So that way, if you're looking at this before that date, there's probably not going to be data. So yeah, and just to note, how it generally works for us is the data gets collected on our hardware, and it gets collected locally there, and then it's basically a big batch process once all the data comes up, and we analyze it and develop insights for it. This is just a bit on our scale, specifically on the global health side. To date, we are now in 16 African countries. That ranges from small regional deployments up to full national scale deployments. This has grown quickly over the last couple of years. And again, this is just our global health work. We have a lot of other global scale within our non-global health. We have usage across, I think it's 70 countries now, and we're expanding in Latin America right now. Something that's kind of important here is I included the partners on the right. So these are a number of our global health partners, and they've been very key for us when we think about deploying a solution all around the world. You're generally not going to be able to just get on a plane, show up in a country, and deploy it and have users and have it all work. If you can, great, but you're probably going to be working with different international partners. And a good example for us was Path there. Path was one of our first global health partners. They are a great organization out of Seattle. They do a lot of R&D work for global development, working closely with the Gates Foundation. And they, for example, were building a new vaccine carrier for use of vaccine transport around the world. They needed their approval from the World Health Organization. We were able to very early on, before we had anything working, come in and help them collect more data on a contract. What that allowed us to do is get really early feedback on our product, understand how it works in these environments, really see firsthand how low connectivity these places are. That was very critical for us, so looking for opportunities like that. If we wouldn't have been able to do that, I honestly don't know what we would have done. Okay. This is kind of an interesting one to show how you can still bring a lot of value and insight even if you are in these low connectivity, low infrastructure areas. So within global health and specific, well, on the right is an example of us collecting data in a similar fashion, but if you'll notice here, the average temperature at 9 a.m. is about 5 C. So, the most common vaccine range is 2 to 8 C, so 5 C is pretty much right where you want to be. So average temperature at 9 a.m., pretty much right on. Average temperature at 5 p.m., pretty much right on. Well, if you look at the average temperature at 5 a.m., just a couple hours before they might start their day, it's double where it should be. And what that actually means in practical terms is there's up to 70% or so of shelf life that is lost over the ideal. And so really what that means is in this kind of like completely analog scenario, they are missing 70% of the actual product degradation. So they might think that that vaccine or that product is completely good. They are missing that full picture of what's happening overnight when they're not recording it. Well, we're able to come in, record the data locally on our device, and in this scenario, what they do is they'll come and get the data only about once a week in this scenario. So it's recording that entire week. They're getting that full picture locally. They come at this facility. There's no connectivity at all. They transfer the data from the device to our phone just over Bluetooth, so that now it's sitting locally on the phone. And it'll go back to the city center where they do have connectivity, and it automatically sends it up. And then someone back at the Capitol can start seeing, oh, actually there's a real issue here, and they can take action. So that is how we kind of bridge the unconnected and connected worlds. And quick bit background on the insurance. Some people are surprised or confused when we mention that we also work in insurance. It is kind of an interesting journey that we've gone on, to be honest. But as a reminder, our mission is to reduce waste in the supply chain. And historically, one of the big ways of making a big impact on certain markets is creating different financial incentives. And the insurance markets have actually done a very good job. And specifically, we're talking within commercial insurance. No comment on the kind of personal lines between auto and health and things like that. That's kind of a whole nother world. But within the commercial lines, there's a lot of examples of really insurance changing the market. So some of these, if you can't read them, in the upper left here, this is U.S. medical professional liability payments. So basically, starting in the early 90s is when insurers actually started taking risk around physicians and malpractice suits and things like that. There's now a real disincentive to perform well and to not mess up, simply. Same with U.S. structure fires. So that's going back to 1980. That's when insurance really started coming around for that. So they started incentivizing property owners to install sprinkler systems and have better construction methods and things of that nature. You can see what happens over time. Same thing for general liability and workers' comp. And so we have a, excuse me, a really convenient correlation. So food going bad and food waste essentially results in a claim. So claims and food waste are very highly correlated. And so what that allows us to do is not only come in and build a good sustainable business from insurance and being able to provide better risk protection, better rates, things of that nature, but we can create those financial incentives so people will actually collect that data, collect that data, do better risk management throughout their system, things of that nature, so that way we can actually reduce the risk and give them better protection. Yeah, all right. So let's talk about some of the challenges here. We encountered all kinds of challenges as we were doing this over the last 5 years. Again, I'll focus a little bit more on the technical side of things. There's a million business side challenges. That is a whole nother presentation probably. But I wanted to just kind of sum it up into 3 key areas as we were building our solution and deploying it. So connectivity, reliability, and user experience. So on the connectivity side, we had this, I kind of mentioned this a little bit already, this challenging paradigm where the areas that we wanted to serve the most by nature had the least connectivity. So we had this interesting challenge where a lot of people might be deploying and they want to deploy to these high populated areas where there's great coverage. Great, you have a million options. We didn't exactly have that. We also wanted to make sure not only were we serving it, but we had to get pretty granular data from these, what we would call data dark zones, and then get it back to a place where we can centralize it. Because data loggers that existed for decades, that's nothing new, but what happens generally is that data go and gets lost and never centralized, never stored, never analyzed, and that was the whole point, is that it's one thing to be able to prevent, or to understand if something was good or bad right at that point in time, but to prevent it from happening, you need to centralize that data. We knew that we were going to work not just only in remote Africa, even though that was a big deployment area for us, but also, like I said, inside shipping containers, congested warehouse, things like that. When I mentioned connectivity here, a lot of it is like on the actual end edge devices and the connectivity that you are or are not going to have. But there's other connectivity challenges as you're deploying globally. So one kind of interesting story was one of our first African deployments was in Uganda, and myself and one of our engineers was there doing the first deployment, and everything was actually working, thankfully, from getting the data coming from our device to our mobile phone in that scenario, but we couldn't get anything sent up to our cloud platform. And after many days of digging through it, we realized that recently, the Ugandan government at that time was blocking Netflix. Well, Netflix at this time was using AWS, and the way they blocked it was blocking everything in AWS. We are hosted in AWS. You can see where the challenge is. So we had to reroute our traffic all around the world just to like do that. So like connectivity expands to all kinds of areas. You'll see something when we talk about, or I mentioned under the solutions area about just like making sure you're physically there. We never would have caught that unless we would have actually been there ourselves. So that's one of the biggest learnings that I can communicate here. Under reliability, again, when you're deploying these solutions where there's going to be periods of time where you don't have connectivity, where you're not quite sure, if your device is not reliable, if you really can't count on it, and it's not built from the start to expect those scenarios, you're going to be in a lot of trouble. So for us, if we have a device, it gets sent out, maybe it starts in a high connectivity area, it might go weeks out at sea and arrive somewhere else around the world. If we can't count on it collecting data that entire time and arriving and being able to operate as we expect, the whole premise of our offering is null and void. So we had a lot of challenges early on about just our reliability. So on the hardware side, for example, our earliest prototype, we were monitoring a shipment of cocoa out of Cote d'Ivoire up to Estonia. We didn't properly put like one of the sensors to sleep as it should every time it's going through its cycle. 3/4 of them all died by the time they arrived, even though we should have had plenty of battery life. You know, little things like that. So it's not fun, you know, convincing a partner over months to like do this, and then you do it, and then you're like, oh yeah, we actually have no data to show you. So those are not fun scenarios. Reliability also goes to obviously the harshness. So as you're working around the world, there's a lot of different high and low temperatures, humidity. And for us in a shipping container, it's such high humidity, it literally rains inside a shipping container. So you had to account for that. Forklifts driving off over it, things like that. Yeah, actually, that's a picture of one that a forklift drove over. You can see the condensation on the left on that one. That was just a off-the-shelf one we were doing. So just some examples of the harshness. And then obviously for us, the BLE connection was really important to make sure that that was working reliably. And then finally, on the user experience, I mentioned this a little bit as well, how important this was going to be for us. So mentioned data loggers have existed for decades. There's nothing new. And on one hand, you could say what we've built here in our hardware is nothing different. It collects time temperature data in the most simple form. But all the other ones historically were really clunky to use, bunch of buttons on them, confusing screens to navigate. You had no idea. You needed a whole manual just to figure out how to use this tiny little thing that was just going to collect some time temperature data. And if we wanted to get people to start using them more and in places they've never used them before, as well as get that data centralized, we knew we were going to have to really think about the user experience. And what that translated then to us also was that we were going to have to build the majority of the layers throughout our IoT stack. So that meant our actual electronics and hardware, our firmware, our mobile. We rewrote a ton of this stuff within the Bluetooth stack early on within Android, just to get the reliability that we need. And the cloud stuff was fairly standard, admittedly, but the other stuff, kind of more user-facing, had to be pretty much built from scratch for us. And then also just under the user experience, the cultural challenges. It's important to note that there's all kinds of little things in terms of the interactions. There's obvious things in terms of just like language, but also the colors and the symbology that we assume we understand what, say, a stoplight means in terms of red, green, yellow. That doesn't necessarily translate everywhere. There's an interesting story on authentication that I'll mention here in a few slides. That was a pretty interesting user experience. Okay. Some of the kind of solutions to these different areas. So I'm just going to go through each of these, and then we'll wrap up here. So on the solutions to connectivity, this first point, offline first development, this was the most important thing for us, I would think. A lot of times when you're building applications, you are assuming a lot of connectivity. When you're deploying globally, building IoT solutions, you need to start basically the opposite. You have to assume no connectivity. And for us, there were plenty of connected scenarios that we wanted to build for a good reason, but we had to make sure that you identify the key problems that your customers are going to solve and build those offline. Make sure that they can do that from start to finish. Part of doing that was understanding the difference between great connectivity, poor connectivity, and no connectivity, and those all are very distinct different scenarios. Great connectivity, that's generally the easy one. No connectivity is not easy, but it's fairly like defined. You can like mimic that and you can work with that. It's this like in-between period that you'll encounter, which is poor connectivity. So it's going to come and go. You're going to have very low bandwidth. Maybe certain assets are going to transfer great. Other ones are definitely not going to. So really understanding all those different states and how your key user experiences are going to behave in each of those states is very critical. Consider the authentication approach. Are users going to need to authenticate ever? What point are they going to need to authenticate? And presumably they're going to need connectivity for that, so understanding where your authentication lives within your application is important. Consider eventual consistency. So for us, I think I briefly mentioned, we make sure that we don't interrupt the user experience even if we do lose connectivity. So again, we will schedule something in the background, wait for us to get connectivity, things like that. Test with various networking tools. So our team does a lot of testing and simulation of these different kind of high, low, and no connectivity. Charles Proxy is one that we use, specifically the bandwidth throttling feature. It's great. You can really try to mimic that. And then again, when you are going to have these more offline scenarios, you need to plan for more complexity throughout your system. So you are probably going to have to duplicate logic throughout our system. That's what we had to do. So we needed to make sure that a user was going to understand if something was good or bad in the most remote parts. For us, that means a certain logic to understand when there's alarms. Okay, well that needs to operate completely offline, whether that's on the phone or hardware, but then someone in the back office and say the Capitol also is going to need that, and they might not be talking to each other always. And so we had to duplicate logic, which is obviously it's just more work, but it's more testing. You need to make sure that you have consistency through it, things like that. So it's just really kind of planning in your development process. There are, let's see here, moving on to, I guess, the connectivity selection. So probably a lot of you know there's a lot of different connectivity options out there, ranging from cell, obviously, satellite. There's new IoT, NB-IoT, Cat-M1, things like that within the cell networks. Obviously, Bluetooth, Zigbee, all those different ones. They all have different trade-offs. And you need to consider what is your power scenario, what is the infrastructure that you can expect all around the world. It varies greatly. So I included a map here. So this map, if anyone knows, feel free to chime in, quiz you a little bit. This is an up-to-date map of all the new, okay, I guess not. Let's see if this comes back. Do you mind logging into your, I'll just explain it. The map there was showing the IoT cell network deployments all around the world up to date. And so that's the NB-IoT and Cat-M1. Well, what you maybe notice is that there's only one country in Africa that even has one deployment of those, and it'll be many years to come. I mean, they're still working on deprecating their 2G networks, not even anywhere considering these new networks. So, and that it's not just Africa. There's a lot of the Middle East there, a lot of South America. So a lot of parts of the world just do not have these. So when you really have to understand what the options are. The other challenge there is that is interesting as that map is, if you really want to drill in at the country level, there is very little resources to understand what the real coverage is of any of these. There's no good central place to say, yes, you are going to get coverage in this city or whatever it might be. The only way we've really been able to prove that is just getting on a plane, actually having devices deployed there. So yeah, that's that. And then the last is get on a plane. I've kind of touched on this. Again, you will never be able to fully mimic it. Test everything you can here, but you got to get on a plane. You got to go there. You got to truly experience it firsthand. Okay, solutions to reliability. So first and foremost, your firmware. This is one of the most important things for us. What I've seen with a lot of other companies building IoT solutions and hardware is that they will contract their firmware, and that might work for a prototype and things like that. But there is so many nuanced things that you will just not get when you don't have it in-house. For us, bringing it in-house was one of the most important things we did. We were really lucky that one of our first employees was our lead firmware engineer. That's him, Sydney, in the upper left there. Him sitting in Senegal programming devices, I think. So just want to emphasize how important that is, because again, if your solution dies out in some scenario that you didn't think of, if you didn't build in that redundancy, you're kind of SOL. Over-engineer. So for us, there was certain kind of planning within our hardware. So our power budget and our data budgets were some of the most important things we had when we were building our solution. It might be a little bit different for you, but for us, we were battery powered. We need to make sure we collect a lot of data. So those are what we really thought about. And simply, we just made sure that we planned out everything and what we think that the solution can sustain, and we just cut it in half every time. Everything gets cut in half across the board because there's a lot of times, again, you don't know what's going to happen. So there's an interesting story that actually happened earlier this year that this really paid off for us. So if you all remember in the last year, there was 2 different container barges that got stuck out at sea, one in the Suez Canal and one in Chesapeake Bay. The latter, one of our customers had a shipment on it. We were monitoring it, so our devices were on there, and it was stuck out there, and it was stuck out there for a couple months at least. I can't remember exactly. Well, and everyone just assumed it, and we were monitoring a bunch of crab. Everyone assumed it was all bad. Well, sure enough, it was also beyond the prediction of how we proclaimed our device would last for. So we're like, yeah, this is probably not going to be great when it comes in. Well, good thing that we cut those budgets in half, because we were monitoring the entire time. We had the full picture of data. We were actually able to show that that crab actually was still good. So we saved $300,000 worth of crab from completely getting destroyed. It still went out, and then we actually are able to save them on their insurance too because of that, which was a pretty cool scenario. So that's what it kind of gets you. Manage expectations. Hopefully this is a pretty obvious one, but I always like to remind people of this. This goes for any piece of technology that you're building, but especially at the kind of hardware end of things. There's so many other things that can go bad, and a lot of times people have this weird idea that when they see a piece of hardware, they just assume it's complete and ready to go. And is this their kind of interactions with physical things in the world usually? Well, that's not the case. Just like with anything else you build, the first versions are probably going to have more issues. And so making sure that you set expectations with your partners, with your customers, that this is the first version. Hey, let's do a beta program, pilot, whatever you want to call it, and bring them into the fold too, because if you're more honest and transparent about it, they're much more willing to like tolerate things. That early project with Path that was in Nepal, we had a lot of issues, to be honest, and we were honest with them every time, and we actually like exposed to them, hey, here's what happened, here's blah, 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 here's how we're gonna incorporate the feedback, yada, yada. So thankfully they were patient with us and they stuck with us through that, but you have to be honest about the expectations. And finally, get on a plane. You can start seeing a theme here. And this is the last thing here, solutions for the user experience. So I mentioned a little bit, identify the different experiences that you want and build those locally, build extra redundancy in that, spend double, triple the amount of effort to make sure that those go well, because if not, you're not going to be able to succeed. Don't make excuses. So one of the things that we have really had to remind ourselves, and frankly we haven't always done well, is like just expecting users to tolerate these poor experiences. And we've always had to kind of pinch ourselves a little bit on those because we're so used to a certain experience and we just expect them to go through a more degraded experience. Don't make excuses around that. Don't tolerate those scenarios. Build it, show up on a plane, see firsthand. There's people here that were just in Senegal that were doing exactly that. See firsthand what those experiences are like, see like how long a page really takes to load and how frustrating that is, and obviously do something about it. And finally, I'm going to just two quick stories on no assumptions here. We had a early assumption, as I mentioned, these devices data loggers that existed, that they're really clunky. They had all these buttons and switches and screens and all these things, and we're like, this is really annoying. We're going to make our very first device with no buttons, no switches. There's nothing on it. You're just going to throw it in a package. Great, it's going to be awesome. Well, so we did that, and then we were out in Seattle on an early seafood pilot, and we said to the guy that was managing that warehouse, yep, just throw it in, all good. And he was like, wait, what? Absolutely not. That is no. And we realized like those devices were going to be sitting in his office, which were room temperature, and he was about to put it in a cold seafood box. And he's like, if I do that, it's going to take a while to acclimate. And when it arrives, they're going to ding me on saying that the seafood was too hot for a couple hours. And he's like, I want to be able to indicate exactly when this thing starts recording. There's a point for that button or that switch or whatever. And we're like, okay, fair point. So we now have a little bit of those interactions on our device, but we had kind of gone too extreme with our assumptions about what they would want and what not want to do. And the other I mentioned I'd bring up is authentication. So this is an interesting one. A couple years ago, when we were really starting to expand across Africa, we had a fairly standard username and password authentication. We were there deploying, and we said, okay, great, we're going to create an account for you. You're going to log in, yada, yada. Probably 2/3 of them were saying like, I don't have an email address, or I don't even know what the password is. I haven't used it in months, or it's a shared account, or whatever the scenario where it was. And so we made a big assumption that they were going to have an email account or email address, and no, not at all. They use SMS, WhatsApp for their communication, things like that. So we revamped our authentication so that way it could use just those code-based that could be sent to phone or WhatsApp or whatever. Otherwise we were literally creating email accounts for everyone and things like that, and obviously that's not sustainable. So that was a very interesting experience. So with that is all I have for you. I'm happy to take any questions, but hopefully that gave you a little bit of light to our experiences. Maybe there's a few tidbits for you, but I'm happy to go into any more detail on anything. Thanks. Yeah.
I had a question about number of devices that you might deploy. What's a big deployment and what's a typical deployment?
Sure. So on the global health side, when it comes to the actual sensing devices, we're deploying in the tens of thousands ballpark, and then like low thousands of the gateways to communicate with those. That's kind of like our standard deployment at this point, because now it wasn't always like that, but now usually we're working with the Ministry of Health, and they are like, okay, great, we want to put together a 4-step plan that gets us to countrywide deployment. So we are, usually covering, thousands of sites across the entire country, and in those sites they might have multiple assets that we want to monitor, and then there's the shipments that go between all of those. So the numbers add up quickly. On the non-global health side, it ranges. We have customers that might use 100 devices a month to we have customers that use 1,000 a week. It ranges depending on the volumes that they're shipping around the world. So, yeah.
So to me, like, the tech seems awesome, the value proposition is clear. What's the biggest obstacle to driving adoption?
Yeah. There is so as I mentioned, there's a lot of, on the kind of hardware end and the actual technology, again, these data loggers have existed, they've been around, and so it's that switching cost. They're like, okay, great, but I'm already doing this today, and trying to help them see what it can be is if we actually collect this data, centralize what we can do once we do it, and we, on top of that, also need to be able to do that and do it for some meaningful period of time before we can show meaningful insights. So that usually at least a couple months, and really is a year. The insurance angle has started to help with that more, because we can show real stronger financial benefits. So we say, all right, do this. Maybe we'll even discount it for the first year. And then after a year, not only can we show meaningful data insights, but we can also give them a great insurance renewal on it. So, but it's that switching for them. Yeah.
Have you run into challenges with the global chip shortage right now and having to rework your hardware?
Yes, very much so. We pay astronomical amounts over for a lot of components. It's a lot on the spot market right now. We tell there's a component on one of our power regulators. I think we spent 70x over or something like that for just something that should cost less than $1. We're paying, I don't know, $60 for or something like that. Just one example. So very painful. We have tried to rework some things so we can have more alternatives on it. That's still, you can only do so much in that, and that's still development work, and you got to take a guess, is this going to come back in that period of time that you're actually developing it? So it's kind of a guessing game there. So in short, it's just been hard. We've had delays, a lot of delays like anyone does. We have some flexibility within our global health deployments in terms of when we actually deploy, so we try to build that into it. It's getting a little bit better now. We have multi-year lead times. We have orders placed for 2 years out, so we do what we can there. But short of it is we're dealing with it like everyone else. Yeah. So. Yes, absolutely. Yeah, that's kind of part of it. Again, it's like, okay, we see opportunities to be like, well, if we work different parts, we could support these other things, but it's going to take us a couple months to get through that. Is that part going to come now, be out a stock, and it's another one, and so it's kind of this whack-a-mole. So, yeah.
Think back to your early days. How do you kind of think about reliability goal setting? We will do X once Y tests have been done.
Yeah, good question, and it's something, admittedly, we have not always done a great job at, because for us, we're building a solution where we have goals of making it work perfectly great, everything like that, but then we're also building a business at the same time where we're like, yeah, we know that this is too high of failure rate. We are not comfortable with this, but if we don't do this, we don't satisfy this contract and we don't move the business forward. So it's this and so we try to soften it with obviously extra support. We're there, we're working with them. We are very generous with our replacements. If something doesn't work, you're getting a new one. It doesn't matter. Like we try to like, soften it as much as we can, but it's not great. We are in certain areas now that we have certain pieces of hardware that have been out there longer and longer, we start to really look at our error rates and things like that. So we're getting more mature about it. But early on, you're just, frankly, just making judgment calls. And that's where you got to set those expectations. You got to have really good, clear communication and support, show up, things like that. So, yeah.
Do you guys have any machine learning solutions like deploy on the edge, like on the devices, or is it not really a need based on the device?
We don't have much on the actual edge. We do definitely we have a whole data science team that does a lot of other interesting work, but that is more, not on the edge. We know that we could. It is a very low resource device. Like we are working very low level on it because again, these are, for example, one of our devices, it runs on 2 AAA batteries for 4 years. So if you kind of think about that span, like the amount of resources that you're consuming is not going to support that much. There are a few things that we've identified that, we do certain machine learning to help frontline workers understand in the case of a fridge, is something going to go bad soon? Is it what the potential breakdown result is? So there's certain things we do there, and we potentially could surface a few little things there, but again, we have to be really careful at the expense of our power, essentially. So, oh yeah, yeah.
Have you seen any other insurance companies like pick up the IoT data monitoring aspect of your business?
Yes and no. So probably many of you on the more consumer lines, you're probably familiar with the like auto insurance. You install a little thing and you get a better rate. There's a number of those. So the kind of consumer lines have done a lot of that. On the commercial lines, not nearly as much. Specifically within cargo insurance, we're definitely leading on that. We are the first people to do that. There's some people that are starting to piece it together a little bit, where maybe it's an insurance company that is partnering with another technology company to try to get them data, or it's a technology company that is like fronting insurance for someone else. Like they're kind of piecing it together. We are definitely the only one that has the full stack, and by that I mean full stack of technology, but also full stack of insurance. So we have, again, we have our own syndicate at Lloyd's. We are a full-fledged paper insurer. Like we can make all of our own risk decisions. We can make our own decision about if we want to deploy technology. Let's say we want to give them an extra 1,000 devices because we think they need it from a risk perspective. Like we can make those decisions a lot easier. So we definitely don't see that often. Cool. All right. Well, I'll stick around if there's anything else, but thank you all.